What is good, Grizzlies? Hey, it's the end of the week and I hope you're doing well. Quick announcement. Next week on Thursday, we'll have our very first quiz of the year. It'll just be on Thursday. I'll have some details about what that'll look like next week, but an opportunity to get some quiz points, maybe bump your grade up a little bit. Today, we have something a little on the challenging side. We're learning how to graph a sine curve, all right? So make sure you have a filled out unit circle. You can Google one or grab one you've already seen. We'll use it to help us a little bit. Let's get started. Here is the general form of a sine function. We have y equals a sine of b in parentheses x minus h plus k. A lot of these letters, you already know what they do to the function. For example, you know that the a value can give it a vertical stretch or a vertical shrink. You also know it can reflect or flip it upside down. The h value is going to shift the graph exactly left and right, and the k value can shift the graph up and down. So that's stuff that you've been learning all year and you have it ingrained in your brain. That stuff is pretty easy. There's one new letter up here, and that one is b. We're going to talk about today what the a value and the b value can do to a sine graph. But first, let's go ahead and draw a picture of the OG original graph. So this is the equation we're going to do together real quick. Y equals sine of x. Notice that the a value would be 1, the b value would be 1, the h and k values are just 0. This is the parent function. Here's how we'll draw our picture. Simply make a y-axis and then just an x-axis on the right side here. And we're going to make 4 points on the x-axis, spread them out evenly. I've got 1, 2, 3, and 4, just like that. Now, let's refresh your memory a little bit on what we've been doing the last few weeks. We've been talking about the unit circle. We've got degrees, radians, we've got coordinates. Here's a sketch of a unit circle. And what we've been discovering is if you took any angle, let's say this angle is, we'll call it theta, okay? If you took any angle, could be 60 degrees, could be 80 degrees, we know that the coordinate is represented by the cosine of that angle. The x-coordinate would be the cosine of that, and the y-coordinate is represented by that's right, the sine of that angle, okay? And I can do that all the way around the unit circle. So what we're looking to do here is graph all of the y-coordinates. We're going to graph the sine curve. Which points on that unit circle are the easiest ones? Yeah, for sure. Like right here at 0 degrees, we have 1, 0, and on the other side, we have negative 1, 0. Up at the top, we have 0, 1, and at the bottom, we have 0, negative 1. These would be the easiest points to graph. And since we're graphing the sine curve, I'm going to be concentrating on just the y values. So when I'm at 0 degrees for the x-axis here, the y value is also 0. So I have a point right here. But when I get to up here, the y value is positive 1. So it goes up to positive 1. How many degrees is that? Exactly. That is 90 degrees. So at 90 degrees, the y-coordinate reaches positive 1. Could you guys tell me what that is in radians? It should be right there on your unit circle. Yeah, this is pi over 2 radians. Sometimes we prefer the radian measure, but we're going to write them both here to start. Coming over here, the y-coordinate comes back down to 0. Right on the x-axis. How many degrees is that? Yeah, halfway around the circle, the y-coordinate is 0. That's 180 degrees. How many radians? That'd be pi radians. Down here, the y-coordinate comes down to negative 1. So I also have negative 1 here. These are the easiest points for me to graph. How many degrees is that? It says it right on your unit circle. It's 270. How many radians? Yeah, that's 3 pi over 2. And then finally, going all the way around the circle, 360 degrees, you can see the y-coordinate is where? At 2 pi. It comes back to 0. So here is what the sine curve looks like and how you can draw it. Maybe you can do this first bump or first half, and then maybe do this second half. And this is a sine curve that goes on forever. The unit circle is cyclic, right? It repeats, it's a cycle. So this keeps going up and down forever to the right, and it keeps going up and down forever to the left. This could simulate in real life a heartbeat when someone has a heart rate monitor. This could be represented by one of those seismographs that tells if the earth is shaking or not. So this is the OG original graph of sine x. Let's talk about some of the details. Now, the a value, whatever number's in front of this equation, could give this thing a vertical stretch and stretch it out thin, or it could smash it down and make it smaller. Right now, the a value is 1. And you might notice from the center or middle of the sine curve to the top is a distance of 1. And from the center to the distance to the bottom of where this curve hits is also 1. So if I was to change this equation and put, say, a 4 in front of this equation, how do you think this would change? How high would the graph go? Exactly. This would go up to 4 and it'd go down to 4. That's called the amplitude. So the amplitude tells you the distance between the middle and the top and the middle and the bottom of the curve. Let's look at a few numbers when the amplitude changes, when it gets bigger and when it gets smaller. Let's get a visual. This sine curve is cyclic, it goes on forever. Let's take a look at what happens when the a value gets a little bit bigger. You'll notice that the amplitude is getting stretched out. It gets bigger and bigger. So watch what happens when I make the a value 5. Boom, you can see the top of the sine curve is 5 and the bottom of the sine curve is -5. What if it was 3? You can see the top of the sine curve reaches 3 and the bottom of the sine curve reaches -3. So that's what the amplitude does. Okay, our next part of this, you can see right here, the graph starts on the x-axis. It goes up to 1, back to 0, down to -1, back to 0 again. And then it's gonna start repeating itself. This is cyclic, right? It's a cycle. So this thing will go back up to 1, to 0, -1, and then to 0 again. And then it'll repeat over and over and over. So one cycle before it starts to repeat itself again and go up to 1, this is called a period. So the period started at 0 and ended right here at 360 degrees, or we like to use the radian measure, 2 pi. So one period here would equal 2 pi. How do you figure out what the period is? You're gonna take 2 pi and you're always gonna divide by whatever the b value is. That's where this comes into play. So right here, I see that there's no number in front of x. In fact, we only have 1x. What's 2 pi divided by 1? Well, it's 2 pi, which means that the period would start repeating as after we reach 2 pi. So it started at 0, went to +1, back down to 0, -1, and it's gonna start repeating here once we reach 2 pi. That is one cycle or one period. Here's the equation of how to find the period. Let's take a look at what happens when the b value gets bigger and gets smaller. Let's see what it does to the graph. Let's take a quick look at what happens to the sine curve when the b value changes. So the b value controls the period. When is it going to keep repeating itself? As the b value gets bigger, you can see that the period or the cycle gets a little bit smaller. It gets smashed together. So right here, you can see that there's a few cycles that happen even between 0 and 5 radians. Now, as the b value gets smaller, you can see that the cycle gets a little bit bigger, the period. It takes a little bit longer for the cycle to repeat. So that's what the b value is doing to the graph. Let's do one example together before we have you try a few in your homework. So here's the equation we're gonna graph or make a sketch of. We got 2 sine of 2x. Right away, the a value equals, sweet, and the b value equals, exactly. Let's start with a y-axis and an x-axis. And we're gonna make 4 points. 1, 2, 3, 4. That's all we need. We're gonna draw one cycle of this equation right here. Let's first start with the a value. The a value is 2, so what does that mean? The amplitude is the distance from the center to the top of the graph. So I know that distance is 2. It's also the distance from the center to the bottom of the graph. So I know the highest that this curve can go is 2, and the lowest that this curve can go is -2. So I'm just gonna label it 2 and -2 here. Now, the b value equals 2. That helps me find the period of the graph, one cycle. The equation is 2 pi divided by whatever the b value is. So 2 pi divided by 2 gives me a value of pi. That means one cycle. This sine curve is going to go up, back to the middle, down, back to the middle again. And before it starts to repeat, that distance is a distance of pi. One period, one cycle. So that distance is pi. I've got 4 points I want to draw here. What would be in the middle of that? What's half of pi? Sure, it's just pi over 2. That would be half. So to draw my sine curve, I start here in the middle at 0, 0. I go up to +2. I come back to the middle, the x-axis. Over here, I come down to -2. Then I come back to the middle where it starts to repeat again. We have one period, one cycle, and that period equals pi. I'm gonna draw my best sine curve, try and make it as smooth as possible there, and I'm done. Not too bad. Now, if you want to take it an extra step further and be a little more detailed, you could label the coordinates on the x-axis here. So like this is pi over 2. What would be in the middle of that? What would be half of pi over 2? That would be pi over 4. So here's 1 pi over 4, 2 pi over 4, which means this is 3 pi over 4. I'm hoping you were able to follow along okay. Email me, find me in an office hour if you need some extra help, guys. We're gonna have you graph 4 of these in your homework. And just as a reminder, next Thursday will be our very first quiz. It will not be on this stuff. It will only be on the unit circle itself. Have a great weekend. Be smart. If you can't be smart, be safe. We'll see you next time.